Welcome back. This is the final shell problem. At least for these introductory notes, doesn't mean we're done. You have a lot of work ahead of you, but this at least introduces kind of the more challenging side of the problems that we're going to encounter. So this is actually in your book, page 462, number 26, not one I'm assigning for homework, but it's similar to 25, which I am assigning for homework. They have these three lines, curves. Oh, just two. Ooh, and these are a little bit tougher to graph. And then about about x equals 3. We're going to revolve this. So these aren't really nice lines, right? They're both curves. So let's see what it looks like. By the way, this one I'm not going to do disc or washer. So this should be, and we're just going to do one example. This should be hopefully under 10 minutes. We'll see. So you have this wide parabola, y equals 1/3 x squared. And then what does this look like? You should know what this looks like. If you factor out an x, you get 6 minus x. So it's going to touch the x-axis at 0 and at 6. Now I don't know where it's going to intersect this other line. So that will be interesting. I did not figure that out in advance. We'll see what happens. I'm thinking it's out here somewhere. So that's going to look, and it's a, since that's negative leading coefficient, it's going to be a downward facing parabola. And I don't know where this is going to intersect, but probably should figure that out. We are going to have to figure out, we're going to need to know that intersection point. So mine looks like it's about 4. Let's see how accurate I am. So what we're looking for, what we're looking for is where this y equals this one, right? So when 1/3 x squared equals 6x minus x squared. So let's move everything left, and we'll have 4/3 x squared minus 6x equals 0. I just added x squared, a whole plus a third is 4/3, and then I subtracted the 6x. Okay, so we can factor out x, and we have 4/3 x minus 6. So our intersections are at 0, of course, we knew that. And whatever makes this 0, which is, I'm going to go up here just because I don't want to use up a ton of space. 4/3 x, when does that equal 6? Multiply both sides by 3/4. And we get 3/4 of 6, which is 4.5. Hey, that's pretty reasonable. Okay. So this right here is 4.5, and I don't have a solution to this problem, so I'm kind of doing this one on the spot. If it's wrong, I'll just have to delete it later, I guess. So that's at 4.5. Okay. So we are going to take this here, region, it's bounded, and we're going to revolve it around x equals 3. X equals 3, okay. So that was, this can be right here. X equals 3. You know what? I might pick a different thing to revolve that around. That's going to be more complicated than I intended. We're going to change this problem because we can do that. We have the power to do that. So let's get rid of all those little dots. And let's even get rid of this. And let's make that 6. 6. And therefore, there we go. That'll be nice. Therefore, this is going to be revolved around this line. That looks better. Okay, so, and we're only going to use shell. And why shell? Well, disk would be perpendicular to this. Try to make, and I'm just going to do this poorly and then go back, but if I try to make a perpendicular representative rectangle, it doesn't look that bad, but when you get above, notice that right here, above that horizontal line, your right and left edge of your rectangle would be touching the red downward facing parabola, so it would no longer be representative. So we actually had to make two integrals, and one of them would be pretty messy, so we're not going to do that. So let's get rid of those. Instead, we're going to make a vertical representative rectangle. Much nicer. Another reason it's nice is otherwise I'd have had to solve both of these equations for x. Good luck with that, because, well, this one wouldn't be bad, but this one would be, it would not be good. A lot of work. Okay. So let's see what we got here. Shell method. We start with 2 pi. What are the bounds? 0 to 4.5. That's right. What's our p? This is almost why I picked this problem. It's for this moment. P is the distance from the rectangle to the axis of revolution. How far is that? It's not x anymore. It's not y, but it's an x value, which is good because it needs to be in terms of x, right? We're going to have a dx out here in a minute. So it needs to be in terms of x. It's not x, right? This kind of takes us back to kind of what we've done earlier. How far? So imagine you're running a race. You want to run a 6-mile race. You want to get to 6. And you're getting progress on how far are you from the finish line. So right here, you're out of breath already, right? And you're only a half a mile in. How far are you? You're 5.5 miles. Maybe at the 1 mile mark, how far are you? You're 5 miles. Let's say this is what, I don't know, 2 mile mark. Well, you're 4 miles. How are we getting that? We're doing 6 minus your current x position. How do we get your current x position? That's x. So it's simply 6 minus x. That's your p. Might have to think about that one for a while. P is distance the rectangle is to the axis of revolution. So 6 is our goal. That's where the axis of revolution is. Our current position is x, so it's 6 minus x. What is the height of the rectangle? Well, height of the rectangle, this is, I'm not gonna have enough room. Height of the rectangle is, height of the rectangle is it's like 7.1, right? It's the distance between the curves. So it's the upper curve, which is the red one, and the red one was the downward facing one. That was the 6x minus x squared. I would use that rather than the factored form. So this is times 6x minus x squared minus the black one, which is the upward facing parabola, 1/3 x squared. This is one of those, it's going to be tedious to do by hand, so I'm not going to. I might just do a little simplifying, just because it'd be easier before putting it in your calculator. And maybe write this as 6x minus, what's it going to be, 4/3? Yeah, 4/3 x squared. I don't really want to FOIL that out. I could FOIL it out. It's going to end up with 4 terms, right? I think 3 or 4 terms. So, yeah, I think it'll be 4. I think this is one I would allow you to put in your calculator. I don't even know what the answer is. So I just made this one up. You could try it, and maybe I could ask me. But the main thing on one like this is setting it up. So if you feel comfortable setting it up, you're doing pretty well. So we're going to call that good. And you have really the tools you need to be successful in 7.3. Let me know what kind of questions you have.